So we're going to continue with our overlays today. Uh, let's see where we're at in progress on overlay. Rebasing these changes. Okay. Mirror repos. Okay, great. Great. Okay. I don't know if we need that source records. Um, Here's what we're going to do. We're going to, what is running over here? So this is running this repos. Okay. So we don't care about this anymore. So what were we doing when we were testing our overlays? Um, okay. Let's just make a backup of the old bash history here. What time is it? 36. Okay. So it looks like, what were we up to? Overlay. Looking for a nodemon command in here. So what were we doing? Open architecture. Okay. Okay. Okay, we hadn't run any commands yet. Okay. Okay. Let's create an Alice version command. Entities, Alice, Alice, CLI. Okay. Alice version. All right. And so, we're going to have the data flows as operations and all of this stuff and CLI commands combined, but for now, we're just going to do it like this. Results in run. Okay. Okay. And okay, so get single. All right, so we're going to pass a get single operation. And we're going to say the definition is the input spec. And the value is whatever the definition we want is, right? So in this case, we'll say version, alice.version. Okay, alice version. All right, so to do, make this a typing.user type. Okay, so what would that look like? All right, so this is what it's going to turn into. User-defined generic types. So put some references, and we'll put the example. Right, so type var. T, generic T, logged var. Okay. Down, sequence covariant, generic type, number of variables, generic type. Logged var int. Nice, so this is almost like a C++ template. Logged var int. Iterable log var int. Var set 0 set. Okay, new T. Okay, generic T. Okay, so it's just telling you that that's how you work with that variable. This is the values that it will accept. Okay, so we could have okay, so basically the operations themselves turn into types, and so then you can accept. We actually don't want user-defined new type. So possibly this one is maybe, so these user-defined generic types may be useful for operations slash data structure shorthand for data flow definition. Okay. Right, so let's say new type. From typing import new type. Alice version. And it's a string. What if we can we derive a type from a type? I think we can. So we could say Simber semantic version is a string, and Alice version is a semantic version, right? And so then we tie back, right? So we'll input this information as lineage, right? So you know what, let's just do it. To do unify typing interface. with Python typing definition. So make definitions relay inputs with parents for lineage based off Python's typing. All right. All right. So semantic version, Alice version. Okay, Alice version. And then we'll say here's the definition. Okay. Okay. We're just going to leave all that in there. Async for. Async for. All right, we got to fix some imports. Primitive plugin base type could not be determined. Plugins installed. Okay, entry point. Okay, so let's go ahead and mess with this right now. So plugin base is of type entry point. So primitive could not be determined. All right, the primitive of blank could not be determined. All right, raise deprecation warning. What happens? So test. Okay, so the primitive of name could not be determined. The primitive of name could not be determined. Okay, so let's just pop in a shell. Okay, so what do we got? Name, default, param annotation, entry point. Okay, so let's just call it primitive object. Right, anything with object primitive, we basically say, hey, this is memory local. Each arg must be a type. Got DataFlow. Load. union arg type check to, oh, okay, high level data flow. Okay, so this is mad about this load default, which should really be a type, so we'll give it the load default type so it can take an instance of that type. Okay, so, okay. Okay. So we're going to go and we're going to remove that commit. Um, okay. So now we shouldn't have that. Okay, great. All right, wait, we need to see what else was in that commit. No, that was just that. So why did it do that? Oh, because, all right, so what we're doing, git checkout dot dot. So basically, we stashed the changes. That's why the file wasn't there. So we'll pop the changes. Okay, okay. So, okay, dfml overlay dfml. Okay, so this we're going to use read git grep dash c5 remap. All right, let's go look for remap. Okay, here's some remap to response stuff. We'll just grab that file. Okay. Right, so this is our example. I think we actually started with this. So basically, let's just grab this body here and make this the data flow. Okay. Okay, so remap to response. Okay, operations, remap to response, remap.op. Okay, so within remap.op, so in the thread, basically what we decided is that we should do remap and then a remap next level down. So I'll put that comment in here. But basically remap operation. Okay, so these comments really should go in here on the common use cases. So what are they basically, in non-default overlays? You could apply, you could, in non-default apply operation overlay to user. Oh yeah, so basically, yeah, you could have, you could install, yeah, you could have overlays that you have installed that are always applying the prioritizer if you want to, or you could specify context-specific overlays, which always apply prioritization in a certain scheme. Okay, let's get rid of these comments. Okay, is YouTube working? YouTube's working, great. Okay, so what are we going to do? Well, we're going to run remap to response. Remap to response is an output operation. So within that output operation, we're going to have another output operation, which is remap to response again. Okay, so get Okay, so keep in mind that I believe the remap to response executes the subflow within the parent flow context. So we're preserving, and that's what all the output operations do, I believe, is, yeah, they execute within. Yeah, remap to response executes the subflow within the parent flow context, so it doesn't create a new input network context for the subflow, right? So that get formatted message, get single op, can reach directly into the input network of the parent data flow. Okay, so remap output up and default overlay with DataFlow, which does remap. Grabs all the DataFlow with get multi. Okay. So let's use get multi on our inner flow. Okay, so we'll call this get data flows. Or let's see. Get data flow. Okay, so wait, so the data flow is passed as an input. We basically run this merge. So we're going to run a merge and we're going to grab so when we run the overlay and overlay apply, it will spit out a new data flow. The new data flow will be all right, so let's add this await here. Diff mount overlay. That is async. Great. So apply dataflow.definition. Okay, so we want this to do diff mount, or let's see, dataflow.definition.name. All right, so grab the data flow. So merge data flows. Or let's see, overlay. All right, okay. So here's what we have to work with. All right, so this is the default overlay, which should go through and it should grab. Okay, so it takes the data flow definition as an input, and then it needs to convert. Okay. So convert, so DataFlow to dict, right? DataFlow to dict. So actually, can we just pass a lambda? I think we can. Let's see. DataFlow, DataFlow. DataFlow. Can we pass a lambda up? DataFlow, DataFlow.export. Okay. All right, so we can say DataFlow to dict, so we can call this DataFlow to dict operation, which will do this export, right? And then we'll call the merge operation. Actually, we can maybe we'll just define them all here, and that will just be simpler, right? So merge goes and it takes a outputs, right? So DataFlow. All right, so DataFlow is dict. So we'll just say definition. Let's play with the typing stuff. So from typing import new type. All right, so what are we doing? DataFlow as dict. So new type, DataFlow is dict, dict, right? Okay, so now we have this DataFlow as dict. So here's the DFML definition. All right, so here's the DataFlow as dict. All right, so we imported definition, we imported op, op inputs. Okay, so merge takes DataFlow as dict, and so we have one input definition. We output it as a DataFlow as dict. We merge it. Which is here, right? Merged DataFlow. Let's see, flow to merge. Okay, so this is merge to, merge dash merge source. Right, so we're merging into this one, right, and we're merging a regular data flow, list append, okay, so where's the regular merge? Okay, where's this merge? DataFlow merge. Oh no, wait, that's the function we want. Okay, util data. Okay, 1, 2, list append. Okay, so we can say 1, 2, list append. And then we can just pass the merge function, right? So we can say this is an operation, right, which describes the merge function from dfml util.data. Right, so I want the one input to come from, we want the one input to come from DataFlow as dict, right? And then we want the two input to come from here's the input data flow. So maybe we have like a data, like an overlay, right? So maybe we have an overlay definition, right, which derives from the data flow definition, right? All right, so data flow, or let's see, this derives from the data flow definition. The data flow definition will be the class itself. This would be a new type, which says new type blank data flow. Let's see, overlay data flow. And actually, this really belongs with the overlay stuff, right? So from dot dot overlay, or let's see, we're in overlay from dot overlay import overlay data flow, right? And we will call it okay, remap not defined. Formatter not defined. Okay, so this to do make this. Okay, so let's just play around with this. Get type, get origin. Okay. All right, we'll import these from here, and that way they'll have their stubs if they aren't around. Okay, so all right, this is quick hacks here. So all right, so convert new type to definition. Right, so how would we do this? Well, let's take a look. So what was it that we wanted? It's this overlay data flow in this instance. Okay, we already added it there. Okay. Cannot import get type. Okay. From typing import get origin. All right, let's see. Okay, get args from util data. Oh, all right, just a wrong term. Okay, so that was for, okay, so let's try to inspect these types. So int is not a user ID. Okay. Okay. So no information via get origin or get args. So let's look at new type itself. Let's see what kind of information it provides. So qual name, super type. Okay, so let's see if anything uses super type. Nothing accesses super type. Okay, so we're going to access super type. How do we check? Let's see. Use instance. All right. All right. If it has after super type. Okay. Super type. Useless. Okay, so there we go. So it's super type. def find primitive new. Okay. Okay. So this will return us. So okay. So what are we going to do? We're going to say basically, hey, we're going to make this recursive function that goes in, tries to find the correct typing information. Uh, so new type has no member supertype. Are you sure it is a typing dot new type? All right. All right, let's find the primitive of. All right, if has type, supertype. Okay. All right. Primitive types. Here we go. So if it's in this list, return the type. Otherwise, oh, we forgot to actually recurse in. Find primitive, find primitive. Okay, so if it's supertype, so So if in type return object. Okay, so new type is function locals new type. Okay. Find primitive overlay. So pass in the thing. Well, what is it? It's this overlay data flow. Okay, so what's the super type? It's data flow. Okay. 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 All right, so if you pass something, what we would like is to say overlay data flow for 2. All right, so the problem we had with these was that, oh, there's no default values. So we'd like this thing to take overlay data flow. New type to definition. Overlay data flow. So we'll integrate it into the whole definition stuff later. Okay, so we find primitive qual name, and we do okay. All right, so we're writing a little console example, and we're saying that if you call this thing and you pass it a new type, um, So from typing, import new type, right? And then import this new type to definition, and then call new type to definition and say, this thing is a string, its value is feed face, and so then it'll say feed dot face. Okay, it's just qual name, and which we'll just leave it as feed face. So eventually, to do split on capital letters into lowercase dot separated. And that'll just help us with name spacing and keeping track of things. Okay, so overlay data. Okay. New type to definition, 77. Okay, list append. Okay. And in this case, we're going to do, we're actually just not going to pass list append. Okay, so this overlay data flow. Name. Data flow is dict. All right, oh, wait, new type. All right, great. Okay. Okay, so data flow is dict. All right, so here's the overlay data flow. All right, df base. Let's put this stuff in here. All right. So new type to definition. Okay. Let's do this. Param annotation. Okay. New type to definition. All right, so we'll say if this thing has this super type, try returning this is subclass. Is subclass. Okay. You have to throw this is class check on if you run if we run Python will get mad at you for calling is subclass on something that you weren't sure was a subclass. Okay, so, but it's moved from being a function to a class. So let's go back to 3.8. Right. So here it was a class, right? Let's just check if it has attributes name and super type. This is typing.new type support. Okay. Plugin base could not be determined. Okay, we'll just call it an object. So this is in create definition. So this is where we're going through and creating. So this is where we're going through and creating in DFML, DF base. This is where we're creating the definitions on the fly based on the function signature. KWRX inputs. Okay. So if we receive an operation in so DFL, DF type. Okay. So here, if we come along an operation, or actually within an operation, DF base, operation, or no. So if we come along an operation, from dict, data class frozen true, entry point, think what we want is def post init. So effectively, so for input in item in iter tools dot chain self dot inputs self dot outputs dot items. Or okay. So take types, make them into definitions if you see them in the inputs or outputs. Okay. So if not is instance definition definition, and we see that it's a type, then inputs item. Fine. Fine. All right. Self.inputs, self.outputs. Self.conditions. Okay. Okay, if for definitions in if definitions if definition container in blank, so if definition container definition container, so list. Okay. Iter all right, so for key value. Okay. All right. So what did we have to do here? So basically, we wrote a little post init on the operation, which will go through, and after it's instantiated, it will look at the inputs, outputs, and conditions. If it finds any things that are, it'll go through and it'll update. Then it'll rewrite those definitions, which are types, into real definitions, which will it will create from the new type to definition mapping stuff. So we'll go ahead and take this out of there, put it back in types, or put it in types. So okay. Oh yeah, this is definition role. Okay. So this will do key value, or it'll do um, enumerate for the conditions, which is a list. And that way we can have the same inner loop. So we'll say convert all typing dot new type definitions to definitions. Okay, overlay data flow, not defined. All right, let's try it. All right, well, it ran. That's exciting. So parameterization is not defined. Primitive types. Oh, was it in base? Uh-oh. All right, so we're going to import them. Now from types. This is what I get for trying to auto format. Primitive types from default utility data. Formatter is not defined. Yeah, this probably should go in util data. Okay, so what do we got here? So we moved around the types. We created a default type, or so we're creating types based on objects if they don't exist, and we moved the primitives into the other file. Okay, and we're converting the definitions. Okay. All right, so then we're going to just add this stuff here where we all we're going to do is make a commit where we remove the primitive types, right? So we'll just commit that, df types moved primitive types list, right? That's what we did there. Okay. Right, so that's what we just staged. Right, so this is what we have left. Okay, so now what else did we do here? So this is its own thing. And what happens here? So df, so create op, create definition. So create definition with object as object. So for unknown types, set primitive to object instead of raise. Okay, so now we've got what, just our type conversions here, right? So find primitive. Okay, so this is this new type stuff. So let's add this. All right, get commit sm df types add. All right, great. Let's see what we've got. Okay, so what did we do now? So we said so this is a commit where we said df types operation auto convert typing dot new type to definition on posting it. All right, what else did we do? Okay, so we have this thing that says create definition. So if we are running create definition and we're past an annotated parameter, so one was basically, hey, if I see it, so we're defining it. So let's see. Okay, so this says, right, so when we're automatically creating a definition, given a function, auto convert to, I'm posting it, so, okay, this is for typing dot new type auto create definition. Okay, wonderful. Let's push that up. That was a lot of good stuff. Okay. Hello. Okay. Okay, in progress on overlay. Okay. Okay, so this shows us the difference between our current tree and the stash. Okay, so it looks like that git multi-data flows merge spec was in this tree. All right, I think we had the right stuff in our tree before we rebased in. That looks like the same commit to me. Okay, so we pulled in changes from the manifest branch, log walk reflogs. Git log in progress. Diff the stash. I'm confused. Didn't we drop a commit? Okay, so this, whatever this is, was after posting it. Okay, good. Okay, so this is where we want to be. So check out manifest. Okay. God damn it. Didn't we drop that commit? Where's my walk reflogs? Motherfucker. Is this it? In progress on overlay. Add new tab to post net. Auto create, post net. So what about, I thought we dropped that commit is the only thing. Right, so in progress on overlay. Move primitive types. What happens if we look at this? Does this thing have that commit in there? It does not. Move primitive types. Does this? It does. In progress on overlay. So for unknown type, So what about this? What about this? That one has a 2. Okay, I'm confused. Where are we? What's going on? Why is this here? I'm concerned. Okay, so back to our overlay DFML matter. Okay. Okay, so merge overlay data flow. Okay, so the inputs is the data flow. Right, so the inputs, we're gonna forget about formatter for now. Okay, so overlaid. So at the top level, the output should be overlaid. Okay, and the definition that that's going to be, and then we're also going to have a operation in here. So we're going to have an operation in here which converts this, which does the from dict on the resultant data flow, right? So we can do data flow from dict and then export it. Okay. And then data flows dict. Okay, so data flow to dict. So we merge everything. So we merge everything. So we run remap to response. We take the output of remap to response. Okay. Okay. Formatter. Get formatted message. Okay. So we do get single and we remap the output to be response. Okay, so we're primarily leveraging Remap just for the ability to, so that's get single. So overlaid, um, so overlaid with the response, formatter, name. Okay, so this will create a dict that says get formatted message, and within that, response. Response should be hello world. Response will be hello world in this example. So get formatted message is then get formatted message contains hello world, and then we say remap to response. DataFlow to dict. Overlay DataFlow. Okay, so we combine all of these together. So this is the main package overlay. So this will be merged with everything else. Okay. So this will be merged with everything else. And then the result is that any data flow produced, so data flow goes in, things happen on data flow, any resulting data flow objects go out. Okay, so we need to be specific about this being the input flow, right? So this should be something like overlay data flow to data flow to be overlaid. Okay. So now we're gonna have to come in here and say, okay, so input definition. We'll add a post-init on this to also convert the definition on the input objects. Oh, the input has an init. Okay, so if so automatically convert non-definition. Auto convert non-definitions into definitions. So auto convert new types into definitions. Okay, so if not is instance definition. Oh yeah, that's right. For those auto-created definitions, it's a little bit confusing on that. Okay, so okay, so we'll add that there too. Okay, so now we should be able to pass input objects directly as these types. So definition type. Okay, so data flow to dict. Okay, so input is this overlay data flow and data flow to be overlaid. Okay, so all these data flows get run, and then they may do something on run to modify the data flow. And when they do that, they're going to output a new data flow. Okay, so grab all the modified data flows. No, grab any data flows, right? So they will take the data flow to be overlaid as an input. We'll provide that. The default flow will grab all data flow objects and so overlay will grab any data flow objects produced by other installed overlays, which consume the data flow to be overlaid input. Okay. It will output the overlaid, it will output a results object with the overlaid key set to a merged to all of the returned or all of the data flows generated via other overlays which consumed the data flow as okay. Okay, what is this? Get formatted message. All right, we can forget about that. Okay. So they take data flow to be overlaid. We take data flow. Okay, so overlay data flow. Okay, so 2 is not overlay data flow. It is 2 is okay. Data flow definition. Okay. So let's create a new type, or let's see, data flow as dict.